Alright guys, welcome to the final section of Chapter 9, and it's going to be on geometric series. We've spoken about arithmetic series in our last section, and now it's time for geometric series. So, essential understanding. You can find the sum of a finite geometric series if you know the first term, the number of terms, and the common ratio. So there's three things that we need to know in order to find that finite geometric series sum. Now, definition: converges. When a finite geometric series has a finite sum, the series converges. So if we have a specific number of terms and it's a geometric series and we can find the total sum, we say it converges. If we can't find the total sum, then we say that the series diverges. We say the series diverges when the finite series has no finite sum, meaning we can't get it. Okay, and we're going to look at some examples today. But let's look at what or how to take the sum of a finite geometric series. Okay, number one, the sum of a finite geometric series. There's the sum, and that's going to be equal to your first term times the quantity 1 minus r to the n. Okay, all divided by 1 minus r. Okay, so your r is your common ratio, okay? N is the number of terms, and a sub 1 is the first term. So n is still looking at how many terms do I have of this series, okay? Secondly, the sum of an infinite geometric series. So we can actually find the sum of this infinite geometric series, S, is equal to a sub 1 over 1 minus r. Very important to know that the absolute value of r has to be less than 1. If the absolute value of r is greater than or equal to 1, there is no finite sum. Again, so two formulas here for finite geometric series and infinite geometric series. You can actually find the sum of the infinite geometric series, but again, here with this equation, your r value, the absolute value of r has to be less than 1. So example number one. Evaluate the sum of a finite geometric series. Finite. Okay, so that was our first example. Now, our first series here is 1 plus 2 plus 4 plus 8 plus ... plus 128. I know it's geometric. How do I know it's geometric? Well, it is a series, but if I go from 1 to 2, that's times 2. 2 times 2 is 4. 4 times 2 is 8. Okay, plus ... Now, I've got two setups here. On the left side, we're actually looking for n, because when we look for a finite geometric series, the sum of that, we have our first term times the quantity 1 minus r to the n over 1 minus r. Well, r in this case is 2. Times 2, that's your common ratio. But how do I know how many terms are between 1 and 128 that we take a multiple of 2? So 1 times 2 times 2 times 2, how many terms is that going to be? Now I could say, well, 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64, and keep going and going. You could also do this, and the reason why I set this up really is if we have a lot more terms to deal with, it doesn't really give us an advantage to sit there and count on our hand. Okay, so we have a sub n is equal to 1 times the ratio to the n minus 1. Okay, so we know that 128, our last term, is equal to 2 to the n minus 1. 2 to the 7th is 128, and that's equal to 2 to the n minus 1. Two numbers with the same base, you know that the exponents are equal. So in this case, n is equal to 8. I could have gotten equal to 8 if I would have started at 8. There's 4 terms. So then it's 16, 32, 64, 128. So I would have been able to do that by hand, but this is algebraically how you could do that. Okay? So to find the sum of that finite geometric series, S sub 8, you know how many terms there are between 1 and 128. Okay, with a ratio of common ratio of 2. So S sub 8, the sum of the first 8 terms is equal to first term times the quantity 1 minus r to the 8th power over 1 minus 2. Okay, and that actually gives us a sum of 255. The second example here, I gave you right away sigma notation, start and end. So we're starting with the first term to the fourth term, and we want to know the sum when we have 2/3 to the n minus 1 power. Okay, so we could substitute in, we could have done a sub 1, a sub 2, a sub 3, a sub 4, and plugged 1, 2, 3, and 4 into this, and then added them all together. We could have done that, but we have a rule for that. So we're going to have s sub 4 is equal to, this is finite now, so s sub 4 is equal to 2/3, that's your first term, okay, times the quantity 1 minus 2/3 to the fourth power, okay, over 1 minus 2/3, and we end up with 65 over 27 when we substitute and simplify. Problem number 2. Determine if the geometric series, and if it's infinite, diverges or converges. Okay, so these are both infinite. How do we know? Both these series, because you've got the plus dot dot dot. Okay, so they're infinite. Now, how do we know if they converge or diverge? You look at your R value, sum of an infinite geometric series. So you look at R, in this case, 1 plus 1/4 plus 1/16. You're multiplying each term by a fourth. Your R is equal to 1/4. The absolute value of that is less than 1, so this series converges. It didn't ask you, but if you wanted the sum, it would be 1 over 1 minus 1/4, and so you get 4/3. This converges to a number, so you would get an output here. Converges to a specific sum. Second series, 1 plus 2 plus 4. Well, your common ratio is 2. That's greater than 1. The absolute value of 2 is greater than 1. This is diverges. So there is no number that our sum gets to. So there's no point of putting the rule down. Problem number 3. Evaluate each infinite geometric series. So our first series is 1.1 plus 0.11 plus 0.011 plus dot dot dot. Infinite geometric series. First, I'm going to see if it converges or diverges. So I know that R is equal to a tenth. Okay, we multiply this term by a tenth to get 0.11. 0.11 times a tenth gives you 0.011, and so on. This converges. This is infinite. So I'm going to use S equals first term 1.1 over 1 minus your R value, which is 1/10. When we simplify, you get 1.2 repeating. Second series, 3 plus 2 plus 4/3 plus 8/9. Well, R, again, in this case, is equal to 2/3. Okay? Now, R is less than 1, so this converges, so we can get a sum. We're going to get a specific number for our area, or not our area, excuse me. For the sum, we're going to get a specific number. So, first term divided by 1 minus R. Well, 3 divided by a third is just 9. So that is the sum of that infinite geometric series. Okay, it's going to get very, very close to a specific value. And last problem, problem number 4. Determine if the series is arithmetic or geometric. I just wanted to put 2 examples here just so you could see. You go from 2 plus 4 plus 8 plus 16. You can see you're multiplying each side by 2. And then let's say there was 10 terms. That's a multiple of 2. That's geometric. 2 plus 4 plus 6 plus 8. You're adding 2 each time, or even adding 2 to the previous term. That's arithmetic. When you add a common term to the previous term, that's arithmetic. When you multiply a number to a previous term, you get a common ratio. Okay? So that's it out of Chapter 9. I hope I was able to help you guys. If you have any questions, please leave your answers or your comments below, and I'll get to them as quick as I can. Thanks, guys.